Okay, so this is two sample proportions for hypothesis test. And there are some things that are a little bit different about two proportion hypothesis test. It's not quite as straightforward as the confidence intervals. So there's some things that are going to be a little bit different. For one thing, in the past, we've never pooled. And for two proportion hypothesis test, we will. So you need to pay attention to this first part of the video. So a two sample hypothesis test for proportions is used to determine whether there is a difference between the proportion of two independent populations. Well, that's the same that we said with the confidence interval, so that's no different. And the null hypothesis is P1 equals P2, and or P1 minus P2 equals 0. All right, including no difference. And because we believe that there is no difference, and I'm kind of going to explain the concept of pooling, we believe that the proportions are equal, so we have to actually combine the proportions. So basically, the standard deviation of the two sample proportions is not P1, Q1 over N1 and P2, Q2 over N2. Notice I have a C for combined. A lot of textbooks use a P, but quite frankly, for P pooled and Q pooled, so that you have P, and I just use a C for combined because you're combining the fractions together. And I'll show you how to do that in just a moment. It's very simple, but it is something else you have to remember to do. But I don't like using the P for pool because we have a P value, we have P1, we have P2, and I just thought putting another more PP on the paper was not good. So consequently, I like to call it P combined. All right. So because we believe that, and so basically this is a combined. This is not P1 and Q1. This is not P2 and Q2. This is a different calculation that we're going to have to make right here. All right. So and we believe that they're the same. So because we believe that they're the same, we're going to combine them together. So essentially, P hat 1 equals X1 over N1, and P hat 2 equals X2 over N2. However, we're going to add these together, but we're not going to add them like fractions. We're actually going to combine them. So we're just going to straight up add X1 plus X2 and N1 plus N2. So we're not combining fractions. We're just saying that if we combine them together, we're going to get a better estimate, right? This formula is not on the formula chart and is one that you will have to remember. All right, so you're going to have to remember that. And if you do prefer to put PP on your paper, it's the same formula. It's just different notation. So we only pool, this is super important. We only pool for two sample proportions for hypothesis test. We do not do it for confidence intervals. We do not do it for test for means. We do not pool for confidence intervals for mean. We only pool for two sample proportions for hypothesis test. That's the only thing we're going to pool for. So basically, we're going to have P hat 1 minus P hat 2. And instead of using P1 and P2, we're going to have P combined, Q combined. All right, P combined, Q combined, and it's N1 and N2. So those numerators are going to be the same. The denominators will change based on the numbers. That's the big difference. Otherwise, everything else is almost exactly the same. And this one is blown up a little bit larger, so you can see the actual formula a little bit better. Okay, so this is the formula a little bit better, and this is how you get P combined. Otherwise, everything is exactly the same. So let's go ahead and run one of these. Suppose that in an early election campaign, a telephone poll of 800 registered voters shows 460 in favor of a particular candidate. Just before the election, a second poll shows 520 of 1,000 in favor of them. But at a 10% significance level, is there sufficient evidence to suggest the candidate's popularity has decreased? So P1 equals P2, and this is the first poll, and this is my second poll. So I'll go ahead and define them. The true population proportion of voters supporting the candidate early in the campaign, the true population proportion of voters supporting them later on in the campaign. Conditions, both are random samples, okay? And they did not tell us that, so I'm going to have to assume that 2 telephone poles represent the voting populations. Remember, the reason we do random samples is to make sure that they represent the population. This was not expressly given, so I must assume that that's the case, since it wasn't addressed specifically. Reasonable to assume that the polls are independent, as one poll should not impact the other. That's probably true. And that seems reasonable. And then we need to check the 10%. 800 divided by 1. So reasonable to assume that there are at least 8,000 voters, and probably reasonable to assume that there are 10,000 voters, assuming that this is a large city, town, or state. We shouldn't have any problem with that. The next thing we need to do is check, is our samples large enough for normality? Okay, so we had 460 in favor of them. All right, so that means if we had a poll of 800, this would be 800 minus the 460 equals 340. So 340 were not in favor of them. Here they told us 520 were in favor of them. So 1,000 minus 520 equals 480 not in favor of them. In both cases, we're larger than 10, so they're large enough to use the normal approximation. P hat 1 is 460 over 800. So this is what was initially, this was the early on. Later on, 520 is 0.52. So this is P hat 1, this is P hat 2. And now we need to calculate our P combined or our P pooled. Well, 460 plus 520 is the numerator, and the denominator is going to be, this should be 1,000. 800 plus 1,000. And if I do that, let's verify this math. 460 plus 520, 980, and then we have divided by 1,800. So 0.5444. All right, so that's my P combined. So my numerator, P hat 1, right here. P hat 2 is right here. There's my P combined, and this is 1 minus 0.544 over the N1. P combined, 1 minus P combined over N2. Now you will notice that this value and this value is the same, and this are the same. That will always be the case. You know what? I should have slid that up. So this is P combined and 1 minus P combined. P combined, 1 minus P combined, N1 and N2. And you'll notice, like I said, this numerator and this numerator are the same, or this part is the same and this is the same. And that will always be the case. So stat test, and we're going to run a 2 proportion z-test, which is letter 6, or number 6. And we have x1. Well, we had 460 that were in favor of this candidate out of 800. That was the initial. X2 was 520 out of 1,000. Oops, not 100, 1,000. And our alternative hypothesis was a greater than. Early was supposed to be greater than later. And we press calculate. And I end up getting 2.328, and I have a p-value of 0.0995. You will notice, let's look at this real quickly. You will notice they did the combining for us automatically. There's P combined right there. That 0.55, that 5444 is P combined. Here's P hat 1, P hat 2. This is P pooled or P combined. And there's our sample sizes, 800 and 1,000. So our P value, and I rounded to 0.01, is less than 0.1. we reject the null. There is sufficient evidence to suggest that the true population proportion of voters in favor of the candidate was greater earlier in the campaign than it was at the end of the campaign. It appears the candidate is losing support as people get to know more about them. All right, doesn't say that last part. That last part was commentary, but it does appear the candidate is losing support. And we will do another one of these in the next video.